Yes, am I audible and visible to everyone? Yes, a very good afternoon to all of you. Am I audible and visible to everyone over there? There is no issue? Yes, I am absolutely fine. Hopefully you people are doing great there. Enjoyed in your vacation? Everyone enjoyed? Yes, huh? Nobody studied. Out of 24 hours, 2 hours also not studied. No issues. You got your mind relaxed. That's more important. You got your mind relaxed. That is also required for kind of further studies. Now, once the vacation is over, so better kind of get back into that study mode. I think few of you are still there at home. Those offline students, right? So the thing is, try to return soon. Okay. Madhvi, I don't know, beta. You'll be like information will be shared about the chase examination and all. I don't have any issue. Like I don't know like what is the exact date. It will be communicated by the admin people to you. Need not worry. Harita has studied. Okay, good. Fine. I think Snehilata is saying 8 ko hai. So maybe it is on 8th, right? But I'm not commenting it like officially. Maybe if at all, if Pansar or else anybody else has given you the information, then it could be correct, right? Okay, fine. I think how far we have finished, let me know. I think enthalpy of solution was the last topic which I've taught you before going for vacation, I think, or the holidays. Enthalpy of solution was the last thing. Okay. Fine, good. Then it could be correct, beta. VSP sir has told you then. Okay, now let us get back into the studies mode. So first thing which we are going to learn now is enthalpy of phase transition. Enthalpy of phase transition. Now, as the name suggests, right? As the name suggests, what we are dealing with here, phase changes, right? That means if I take 1 mole of any substance and when it undergoes phase change, during that time, whatever is the enthalpy change, it is known as enthalpy of phase transition. So when I refer to phase change, it could refer to solid to liquid and the reverse process of it, right? Solid to gas and the reverse process of it, right? Or else liquid to gas and the reverse process of it. So these things we already know, right? Similarly, if at all I am talking about solid to solid is also a kind of phase transition. When I refer to solid, you might think that basically physical state is not changing. Still, why I am calling this as a phase transition? I am actually referring to, if at all carbon in the graphite form, that is also present in solid form, that allotropic form gets converted into the diamond form or vice versa. That means allotropes are changing their form. And we are calling that as a phase transition. Reason being, their solid state is not changing, but internally the structure or the crystal structure is changing. Because of that, we are referring it to phase transition. So I hope this is clear to all of you. I'm going to write down the definition. You can also write it. So I'm writing here, the enthalpy change when 1 mole of a substance or of a given substance changes its phase, right? And when I'm writing changes its phase means I'm referring to solid to liquid and vice versa, solid to gas or else liquid to gas, and reverse process also valid, solid to solid. And when I'm referring to solid, that means I'm talking about allotropic transition. Maybe sulfur in the monoclinic can get converted into rhombic and all those stuffs, right? Now here, I am simply going to write down X solid to X liquid. Is it melting or not? So do I call it as fusion or freezing? Do I call this as enthalpy of fusion or freezing? Fusion is melting, freezing is the reverse process of it. So I'll be calling this as delta H fusion or melting. Now is this fusion endothermic process or exothermic process? Correct, Purushottam. Now tell me, is this delta H fusion endothermic, exothermic? Endothermic, exothermic. This is going to be endothermic, right? Endothermic, because the thing is, when you take ice on your palm, it melts by taking the heat which is there in your palm, right? It doesn't start giving away the heat. You don't start feeling, kind of heat from there. So it is going to be endothermic. Now, if I reverse this, X liquid to X solid. So if I reverse it, it becomes delta H of freezing. And this is going to be exothermic, that is delta H freezing. I just reversed the equation, right? Now I'm writing here for a substance, we can say that delta H of fusion is actually minus of delta H of freezing. When I fix the substance, these two are just going to vary in their sign, value is going to remain same, right? Preeti, it's not exothermic, beta. For this, if you are talking about delta H freezing, then this is absolutely correct. Now, similarly, if at all I write down X liquid to X gas, we are talking about delta H vaporization. And vaporization means it is going to be endothermic, that means greater than 0. Similarly, X gas to X liquid, this is actually delta H condensation, right? And this is going to be less than 0, that means it is going to be exothermic. Now here, for a particular substance or for a substance, I can easily write down this as delta H of vaporization is minus of delta H of condensation. Got it? And I think regarding that QR share code, there was some issue. I think when Birmani sir was taking class, that has been resolved. Do not worry about it. That link will be shared to you. Okay. Now here, if at all I am writing X solid to X gas, this is actually representing enthalpy of sublimation, and this is also going to be endothermic always. Now I can write down this in more than one step. Like suppose this is one step directly. So this is, let us say, delta H sublimation. I can break it into few steps like X liquid to X gas. This solid to liquid is what? Delta H fusion. And what about liquid to gas? This is basically delta H vaporization. So for a given substance which is undergoing sublimation, I can say delta H sublimation is equal to summation of delta H fusion plus delta H vaporization. So I can write down delta H sublimation, that is equal to delta H vaporization plus delta H fusion. I am writing the short form here: fusion, vaporization and sublimation. Hopefully everyone is getting it. Whatever I am writing on the board here, there is no confusion. Then next is, even if I write down carbon solid in the graphite form, that gets converted into carbon solid in the diamond form. Similarly, sulfur solid in monoclinic form, this might get converted into sulfur solid, but rhombic form. I'm also calling this as actually delta H transition rather than calling it only as the phase transition, simply writing out delta H transition. Allotropic form is changing, only thing is physical state is remaining same, right? Only thing is allotropes are changing their form, their crystal structure is changing. Once you are done writing, let me know so that we can proceed to the next definition. So remember, I have left one topic like enthalpy of phase transformation, right? So there in your NCERT, it is given all those different definition for enthalpy of sublimation, for vaporization. So we have covered all those things under one topic only, which is phase transition. Okay. Written? Okay, good. Now next one, which is basically enthalpy of hydrogenation. Enthalpy of hydrogenation. Now for hydrogenation, I'm going to write down this as hydro because I'm not writing HYD because you might get confused with the hydration symbol which we have written. This is not a standard one, okay? This is only for, kind of writing it in a little bit of shortcut. Now when I ask you, what is hydrogenation? What do you understand by hydrogenation? What is hydrogenation? All of you read organic chemistry, no? Addition of hydrogen, right? And if at all you little bit recall, you always add that hydrogen across that C double bond C or else C triple bond C, right? So basically C double bond C or C triple bond C, we are referring to unsaturated compound, right? So what you are doing, generation of hydrogen is not hydrogenation, it is addition of hydrogen. Now how do we define this? You take 1 mole of an unsaturated compound, treat it with excess of hydrogen. So when you treat it with excess of hydrogen, that unsaturated compound gets converted into saturated compound, and during this particular transformation, whatever is the enthalpy change, we call it as enthalpy of hydrogenation. Hopefully it is clear to you. So I am writing down the definition. The enthalpy change when 1 mole of an unsaturated compound, 1 mole of an unsaturated compound is reacted with excess of hydrogen to obtain saturated compound. So suppose I am writing here C2H4, which will be having 1 pi bond. You are treating with hydrogen gas. Here it will become C2H6. So delta H for this reaction is going to be enthalpy of hydrogenation for your C2H4. Write this down. And here always remember it has to be 1 mole. This could be anything, 1, 2, anything. According to the stoichiometry, it has to be balanced reaction. Now I am saying this hydrogenation is always an exothermic process. Reason being, you are having C2H4, right? It is more reactive, right? And it is associated with more energy. It is less stable here. When it comes to C2H6, it is an alkane. And we know that alkanes are associated with paraffin name, right? Paraffin means what? Least reactive, low reactivity we say. So basically they are less reactive, more stable. More stable means associated with less energy. I am again repeating it. Here we are having more energy, less stable. Here, more stability, low energy. So you are having a more energy related compound. It is getting converted into less energy compound. So definitely that extra energy has to be liberated out somewhere, and that's the reason it is exothermic process. So I'll write down this one as it is always an exothermic process. It is always an exothermic process. Is it clear? So having learned 2 definitions, after that we are going to see some numericals here. Finished? Now let me give you one question here. Given A solid to A liquid, delta H1 is 100 kilocalorie per mole, and A gas to A liquid, delta H2 is given as minus 300 kilocalorie per mole. Find enthalpy of sublimation of A. Find out this one, everyone. As such, a very simple question, but this kind of question could be asked. Snehalata, some mistake you are doing, beta. Remant has given correct answer. Absolutely correct. 400. When it is sublimation, that means they are referring to A solid getting converted into A gas, right? So you have to find out delta H of this reaction. That is only sublimation of this A. So how would you get it? Basically, this is reaction 1 and this is reaction 2. So you have to reverse the reaction 2 actually. So this is going to be reaction 1 minus reaction 2. You will be writing delta H1 minus delta H2, and which is 100 minus of minus 300. You will be getting answer as plus 400. I think I have given in kilocalorie per mole. So do not do silly mistake. I think only one person has done a little bit of mistake, and rest of you have done it calculated correctly. See, thermochemistry is very simple. All you need to be is more careful what is asked and how you can interpret the things there, right? Very good. Those of you who could do it correctly. Now, next question I am giving you. Given enthalpy of combustion of C2H2 is minus 400 kilojoule per mole. Enthalpy of combustion of C2H6 is minus 200 kilojoule per mole. Enthalpy of combustion of hydrogen is minus 50 kilojoule per mole. Find enthalpy of hydrogenation of C2H2. Solve it. No, Remant, little bit in hurry burry you have done. Those who are getting minus 250, it's wrong. Check it out. Manas, you also check it out. Write down the equation. Without writing down the equation, you cannot get it. Did you balance the equation first of all? Here, whatever is asked, according to that, you will be writing the equation. That means C2H2. So you have to take 1 mole of it. Plus you are having 2H2. Then only you are getting C2H6. Now you have to find out the delta H of this reaction. And this reaction is nothing but the hydrogenation. So hydrogenation of C2H2. And the data given is enthalpy of combustion. Himja, is it plus or minus beta? 300, you are telling me magnitude. Correct. It is minus 300. Correct. Sai Ganesh has calculated correctly. Good. So delta H reaction is what? Enthalpy of summation of enthalpy of combustion of reactant minus enthalpy of combustion of the product. Problem is some of you assume on your own that after C2H2 it will be hydrogen data which will be given to you. Please do not be in that particular kind of confusion. So here I'll be writing enthalpy of combustion of C2H2, which is minus 400. For hydrogen it is minus 50, but there are two hydrogens. Minus for the product it is minus 200. So you'll be having minus 500 plus 200. You will end up with minus 300 kilojoule per mole. Able to understand? It has to be minus, not plus. Okay. Good. Many of you have done it correctly. Good. Those who have done mistake, they identify where they have done mistake here. Next question I am giving you. Given enthalpy of combustion of white phosphorus is minus 100 kilojoule per mole, and enthalpy of combustion of black phosphorus is minus 80 kilojoule per mole. Find enthalpy change for the transition of white phosphorus to black phosphorus. This is also a very simple question, but this could be asked. You never know. What is the answer? I think answer should be like immediately popped up there. Minus 20, very good. So the thing is, simply do not worry, like what is the equation? Simply they have given you white phosphorus to black phosphorus. You have to find out delta H for this reaction, and delta H for this is only transition. So you have to find out summation of enthalpy of combustion of the reactant minus the enthalpy of combustion of the product. Now in this case, I'll be writing here minus 100 minus of minus 80. You'll be getting minus 20 kilojoule per mole. Was it a difficult problem? Yes, Arshad, I think many people, Nafisa, Vamsi, many people have given correct answer. Very good. So the examiner will give you hint in the problem statement itself, whether it is from white phosphorus to black phosphorus or else black phosphorus to white phosphorus, right? Done? Now let us go for learning next one, which is enthalpy of atomization. Now here I am representing it by a symbol delta HA, right? Now, rather than telling you the definition first, I'm going to write down few equations and I want you to basically form the definition, right? So suppose I'm having here CH4 gas. This will get converted into C gas plus 4H in the gaseous form. Similarly, H2OL getting converted into 2H in the gaseous form plus O in the gaseous form. Similarly, you are having Al2O3 solid. It is getting converted into 2Al gaseous plus 3 oxygen gaseous, right? Now here, are you able to see I have taken 1 mole of these substances, and these substances could be in gaseous, liquid, solid, any physical state, okay? And what we are doing is, are we converting them into their constituent gaseous atoms? Are you able to see that? Gaseous atoms. So during this, whatever is the enthalpy change happening, when you take 1 mole of a given substance and try to convert that into its constituent gaseous atoms, and these are isolated gaseous atoms, that means there is no bond here, they are far away from each other. That's the meaning of it, okay? So here simply you can write down the definition. The enthalpy change when 1 mole of a substance is converted into its constituent gaseous atoms. Its constituent gaseous atoms. So here I'll be writing This is what delta H of this reaction is representing the enthalpy of atomization of CH4. Then this is representing delta H of this reaction is enthalpy of atomization of H2O, and this is representing the enthalpy of atomization of Al2O3. Please write this down. Then I am writing two more statements which you will definitely agree with. Na solid to Na gas. For them, I can say enthalpy of atomization is equal to enthalpy of sublimation. Let us try to understand this. After that, you can note it down. Now here, are you able to see solid getting converted into gas? So you might feel it is sublimation, right? Now, so that means it is fine. Now when it comes to atomization part, when it comes to carbon in the solid form, it could exist in graphite, diamond or any other allotropic form. So when it comes to graphite or diamond, those structures you already know, right? So in graphite and diamond, you know that there is bond which is present between carbon-carbon. Now if you heat it, right? So what is going to happen? That bond can be broken between them, or else you kind of put some condition where, like maybe high pressure or something, where the bond between carbon-carbon could be broken down, right? So the thing is, basically what is happening, you are breaking all those bonds and converting them into isolated gaseous atom. So that's the reason it is enthalpy of atomization of that carbon. Similarly, solid sodium is there. Solid sodium means what? You are having sodium, crystal lattice of it, metallic lattice will be there, and that sodium atom, there will be basically metallic bond present. So if you heat it, those metallic bond or else force of attraction will be gone, and you will be getting basically isolated gaseous atom. So that is the reason we call delta H enthalpy of atomization of such kind of species as the enthalpy of sublimation also. I hope it is clear. Finish writing it, then we'll proceed further to the next one. If it is done, just have that thumbs up or something like that. Done? Okay, good. Done. Okay. Now let us go for the next one, which is basically bond enthalpy or else bond energy or else bond dissociation enthalpy. Bond dissociation enthalpy. And I'll be writing a shortcut here for this, which is BDE. For these two, BE. We'll first understand bond dissociation enthalpy, and after that we'll write down the definition. Okay. Now let us say I'm taking here for bond dissociation enthalpy, I'm leaving little bit of space for writing the definition. Suppose I'm having HOH gas. So what is the first condition? You should take a gaseous compound. Okay. So when you take a gaseous compound, and when it refers to bond dissociation means what? You are breaking the bond, right? So you focus on one particular bond here. Let us say OH bond, right? So when you take a gaseous compound and when you break 1 mole of a particular bond, now what is the product which you are obtaining here? Are you getting H gas plus OH gas or not? So when you break 1 mole of a particular bond which is present in a given gaseous compound, compound should also be gaseous, are you getting gaseous products or not? If you are getting the gaseous products, then during that particular process, it is actually bond dissociation enthalpy of OH bond. Let me give this as X1, some value, right? So I'll be writing here the enthalpy change when 1 mole of a particular bond, 1 mole of a particular bond in a gaseous compound, is broken so as to obtain gaseous products. Right? Now still the definition for bond dissociation enthalpy is over, but still there is a minute difference between bond enthalpy and bond dissociation enthalpy that we are going to understand. Now here again there is one more OH bond which is remaining. I would like to break that also, right? Let us say we are breaking it. If I break it, what will be the product? O gas plus H gas, and here will I be writing this as bond dissociation enthalpy of OH bond, and this time I am writing this value to be X2. Now why it is differing here? Because the time when you are breaking the bond, one particular bond, OH bond, the chemical environment here and here, it is differing. That means what? Here one oxygen was bonded to 2 hydrogen. Chemical environment is different. Here one oxygen is bonded to only 1 hydrogen. That means again the chemical environment is different. So when the chemical environment becomes different, so your bond dissociation enthalpy for the same bond in the same compound also differs. Same bond means I am referring to OH bond. Are you able to understand? So basically bond dissociation enthalpy value for a particular bond will differ in the same compound also. Reason being chemical environment is differing when you are going to break that bond, right? Now if at all I replace this H2O gas by H2O2 gas or any other compound, don't you think that OH bond dissociation enthalpy is going to differ? Is it going to be same or else it is going to be different? Like, is it going to be same as X1, X2 or as different from them? Yes, it is going to be different, right? Now, if it is going to be different, then how, then scientists thought then which data, we should be using for, some standard calculation. So what they did, they have collected the bond dissociation enthalpy of this OH bond from various compounds which had OH bond in them. Like suppose H2O is there, H2O2 is there, any alcohol is there. So from them, they collected the bond dissociation enthalpy data. Then they took average of that bond dissociation enthalpy data, and whatever value they got, they called that as bond enthalpy. So simply, I'll be saying that bond enthalpy is average of bond dissociation enthalpy. Do remember this, and in the examination, you don't have to wonder, they'll be giving you bond enthalpy only, right? So if this time now I ask you, what is bond enthalpy of OH bond? So you'll be writing this is average of bond dissociation enthalpy of OH bond, and in that case it becomes X1 plus X2 upon 2. Understood this, everyone? This is important, you must know this. Bond enthalpy or bond energy, it is average of bond dissociation enthalpy, and in the examination you need not scratch your head whether bond dissociation is given or else bond enthalpy. By default they are going to give you bond enthalpy, right? Please write this down, then we'll proceed further. Now here I am writing for a diatomic molecule, if at all I write something like this, H2 gas giving you twice of H gas, does it seem like enthalpy of atomization? Because you have taken 1 mole of this H2 and you've converted it into isolated gaseous atom. Even in H2, you are having one bond here, you are breaking it. So can I say that this is bond enthalpy of hydrogen, right? So for any diatomic species, its enthalpy of atomization will be equal to bond enthalpy, right? So I'll be writing in general, X2 gas getting converted into 2X gas. So enthalpy of atomization, that is equal to bond enthalpy of X2. Finish writing it, then we'll go for polyatomic. For polyatomic, first you understand. Otherwise, little bit confusion could remain. That's the reason I'm asking you. First you understand, after that you can write down. Anyhow, QR code and everything is shared. So for a polyatomic molecule, let us say I'm talking about CH4 gas. I'm breaking all the CH bond so that it gets converted into C gas plus 4H gas. Does it seem like it is enthalpy of atomization of CH4? Does it seem like it is enthalpy of atomization of CH4 or not? Because you have broken all the bonds here, or else, you have converted 1 mole of that particular compound into basically what? Its constituent gaseous atoms. But what we are interested in is how to get the bond enthalpy of CH. That's what is interesting area, or else that is what is our area of interest. Now, in that case, we are going to break that CH bond in CH4 one by one. That means, if at all you are having CH4 gas here, you break one bond, you will be getting CH3 gas plus H gas. That means I am referring to this. You break one bond like this, okay? Now here I am saying this delta H1, let us say this is Y1 kilojoule per mole. And delta H1 is what? Basically it is representing bond dissociation enthalpy of CH bond. Similarly, now once I am having CH3, is the chemical environment different now? Because earlier this carbon was surrounded by 4 hydrogen, now it is surrounded by 3. So the chemical environment is different. So when I break it, so delta H2 bond dissociation enthalpy is going to differ. It is not going to be Y1, it is going to be some other value, let us say Y2, right? So here I will be writing CH3 gas, which is getting converted into CH2 gas plus H gas, and here it will be delta H2, which is Y2 kilojoule per mole. So one by one we are going to break the bond here. CH2 gas, it is CH gas plus hydrogen gas, delta H3 equal to Y3 kilojoule per mole, and then CH gas, C gas plus H gas, and this is actually your delta H4, which is Y4 kilojoule per mole. Now when I add all these reaction, are you able to see this is getting cut here, this is also getting cut, this is getting cut. So I am having CH4 gas getting converted into C gas plus 4H gas. Are you able to understand so far? Now in this case, what we are having is, can I say delta H for the reaction which I have just written, is it equal to the summation of delta H1, delta H2, delta H3 and delta H4? That means I'll be writing this as Y1 plus Y2 plus Y3 plus Y4. Able to understand so far whatever is going on here? Just understand this carefully. And do we also know that delta H of the reaction is actually representing enthalpy of atomization? So can I say that the enthalpy of atomization in this case is Y1 plus Y2 plus Y3 plus Y4? I can easily write like that. Now, but how do we get this bond enthalpy of CH? Can I get this as average of bond dissociation enthalpy of CH bond? So that means what I have to do? average y1 plus y2 plus y3 plus y4 upon 4, and that is representing bond enthalpy of CH, and is it representing the enthalpy of atomization of CH4 divided by 4? Able to understand this, everyone? For making you understand this, that's the reason I asked you, listen carefully. Is there any trouble here? Going on the same line, if at all I ask you about the bond enthalpy of OH bond in terms of enthalpy of atomization of basically H2O. So what will be your answer? Did you understand the question? Going on the same line, if I ask you what is the bond enthalpy of OH in terms of basically enthalpy of atomization of H2O, so your answer would be? Yes, correct. That has to be divided by 2. Because I'll be sharing this QR code, so need not worry. Have you understood this or not? So that we can proceed further. Because based on this, there could be some small question which could be there in your module. Can we go further? You can note it down later on. Is that okay with all of you? Let me know. Correct, correct. Anand, I think Sai is there. Another one. Can we proceed further? Yes, we'll share. In fact, do not worry about it. I can understand, right? Okay. Now, for a given reaction, when I'm talking about reaction, let us say A gas plus B gas, and do not think that they're individual entities. Assume them to be basically a molecular species where bond is existing, right? But for simplicity's sake, we are writing like that: C gas plus D gas. So delta H of the reaction is summation of bond energy of the reactant minus the summation of bond energy of the product. Right? And you can apply this formula only if all the reactants and products, they are present in gaseous state, otherwise you cannot, right? So I'm writing here, all reactants and products must be in gaseous state or gaseous phase. And here as such, delta H of the reaction is energy required to break the bonds in reactant plus the energy liberated during the bond formation in the product. And you should be aware that when you are breaking a bond, energy is required. You have to supply. And when you are making a bond, or as a bond is getting formed in the product, energy will be liberated. That's the reason minus sign is coming here. Are we getting it? And here A, B, C, D, assume it to be molecular species where you are having bond existing. Do not think that they are like, kind of no bond is existing. Now, having, kind of gone through this formula, you might have now, you answer the question which I'm going to ask you, right? Because that is going to be helpful for solving the question. If enthalpy of formation data is given to you in the question, then for finding out the delta H of any given reaction, what do you do? Product minus reactant for the enthalpy of formation, or else reactant minus product? Correct. Madhvi has correctly said. Now, if enthalpy of combustion data is given, then what do you do? For finding out delta H of the reaction, if enthalpy of combustion is given, reactant minus product. Okay. Similarly, if bond energy data is given, what you're supposed to do? Again, reactant minus product. Okay. So be careful with that. Let us go for very simple question now. Find delta H of the reaction. I'm writing down the reaction C2H4 gaseous plus H2 in the gaseous form, giving you C2H6 gas, given bond enthalpy of C double bond C is x kilojoule per mole. Bond enthalpy of CH bond is done na CC bond is W kilojoule per mole. And I would request, only thing is you expand, write down the expanded structural formula. So that you can easily solve this question. Otherwise, some bonds you might be missing it out. Solve it and let me know what is the expression which you are getting. Madhurika, are you online student or else offline student? For some time you are online. Sham, your answer is little bit, some mistake is there, check it out. No, Madhvi, there also you didn't count the number of bonds there. See, Madhvi, silly mistake you are doing. Permanently shifted kya, Madhurika? After holidays, is it permanently shift? You remind me in the last, okay? Now here basically delta H of this reaction is going to be summation of bond energy of the reactant minus summation of bond energy of the product. So basically I'll be writing here, since we are writing for the first time, I'm writing all of those. Bond energy of one C double bond C plus what you are having 4 into bond energy of CH plus you are having bond energy of HH. This is basically for reactant minus of you are having in product, you are having 1 bond energy for CC plus 6 into bond energy for CH. So carefully put the values. I think I have given you X here. This one is Y plus Z minus for single bond I have given you W and this one is minus 6Y. So here it will be X minus 2Y plus Z minus W. People should be getting this. X minus 2y, yes, I think Amrut has done it correct. Harshvardhan also correct. X plus Z minus 2y. Hema Varshini also correct. Hemashri also correct. And here the examiner can replace X, Y, Z, W by basically X1, X2, X3, X4 or else maybe some data is given to you, right? Shall we proceed for the next question here? Next question I am giving you, find standard enthalpy of formation of HCl gas given bond energy of H2 is 100 kilocalorie per mole, bond energy of Cl2 is 60 kilocalorie per mole and bond energy of HCl is 90 kilocalorie per mole. Find it out. Anudeep, is it plus or minus beta? Anisha, you didn't write down HCl. You have written 2HCl. Harsh, you have done same mistake. Did you write down enthalpy of formation? Those of you who are getting minus 20, they didn't write down the enthalpy of formation. They have written H2 plus Cl2 giving you twice of HCl. Do not forget the basic definition there. Those who are getting minus 20, same mistake they have done. I've asked you enthalpy of formation. Formation means what? 1 mole of that compound should be formed, na? That means 1 mole of HCl should be formed. So here you should be writing half of H2 plus half of Cl2 gas. So the delta H not for this reaction is equal to standard enthalpy of formation of HCl gas. So here I'll be writing summation of bond energy of the reactant minus bond energy of the product. So I'll be writing bond energy of H2 by 2 plus bond energy of Cl2 by 2 minus bond energy of HCl. So you are having here 100 plus 60 divided by 2, which is 80 minus 90. So this is minus 10 kilocalorie per mole I have given you, or else kilojoule, kilocalorie. So this is kilocalorie per mole. Able to get this, everyone? Very wonderful answers we are getting. 65, Madhvi. What is the talent you have shown there, beta? How? 65? So those who have done mistake, please identify your mistake and learn from it. That's what I would say. Got it? Yes, you should be careful that you have to write down enthalpy of formation. You don't have to write down any reaction. Your minus 20, when it will be correct, if at all examiner gives you the reaction, H2 plus Cl2 giving you 2HCl. And all of them, they are in gaseous, and then they say find out delta H of this reaction and bond energy data is given. In that case, minus 20 is correct. There is no harm in that. But if at all they have given you enthalpy of formation, so write down according to that. Similarly, they could have given you enthalpy of combustion of any particular reactant. So you have to write down combustion data, and accordingly bond energy data will be given to you. Right? C double bond O, OH bond, all those will be given to you. Done? Shall we proceed further now? Let us go for one more question. Find bond enthalpy of PP and bond enthalpy of pH bond given enthalpy of atomization of pH3 is 90 kilojoule per mole and enthalpy of atomization of P2H4 is 140 kilojoule per mole. I would help you. In fact, I'll definitely give you a small hint. Then please interpret these two. And if at all you are not sure about the structure, do you know the structure of N2H4? N2H4 is like this. Nitrogen, phosphorus both belong to the same family. You can always go like this. So find out. Give it a try. Chandana Shri, you have forgotten enthalpy of formation. Entire teaching is waste then, beta. Enthalpy of formation is asked. You write down the reaction according to that. And whether you have to do product minus reactant, reactant minus product, it all depends on what is the data given. That is the reason before starting, giving you the question, numericals, I have basically asked those things, confirmation. Please revise the things properly. No, Chandana, do not forget it, beta. Need not be sorry here. But the thing is, you please do not forget the basic. Otherwise, what will happen? That kind of answer will be also there. You will be losing the marks. So be careful. That's what I want. I think Bhargav has given absolutely correct answer. Very good. So basically, for solving this question, first of all, interpret this PH3 gas. You are going to break this into P gas plus 3H gas. And here delta H of the reaction is equal to enthalpy of atomization of PH3. And that value is given to be 90. Now we have to find out bond enthalpy here. So delta H of the reaction is summation of bond enthalpy of the reactant minus the bond enthalpy of the product. Now delta H of the reaction is 90. In the reactant, are you having basically 3 pH bonds here? Like ammonia. So you are having 3 into bond enthalpy of pH. And do you have any bonds in the products? You don't have any bonds there. So that means it is 0. So bond enthalpy of pH is actually 30 kilojoule per mole. Similarly, for P2H4, again interpret that P2H4. I am writing each and every step. That's the reason it might feel it is lengthy, but it is not. So 4H gas. Now here delta H of this reaction is equal to enthalpy of atomization of what? P2H4, and that value is given to be 140. So here again similar concept, enthalpy of reaction is summation of bond energy of the reactant minus summation of bond energy of the product. This one is 140. In the reactant, you are having basically one pp bond, right? Remember, I have drawn the structure. So one pp bond is there, and you are having 4 pH bond. This is 0, no bond in the product. So 140. This is bond energy of pp. Plus you are writing 4 into 30, which is 120. You will be getting 20 as your answer. Finished writing? Have you understood this? Everyone? Is there any confusion to anybody? Okay, then one more question. Now you are in fact eligible for doing all the questions which are given in your module for bond enthalpy. We have seen all the cases here. Now, one small question I'll give you. Find enthalpy of formation of CH4 given enthalpy of sublimation of carbon solid is x 1 kilojoule per mole. Bond enthalpy of H2 is x2 kilojoule per mole. Bond enthalpy of CH is x3 kilojoule per mole. Try out this question, everyone. Is it audible now? Fine. I think now there should not be any trouble. I think it is audible now. Okay, good. Now the thing is here, I cannot directly apply the formula of bond energy of the reactant minus product because all of them, they are not in gaseous. So I have to convert it. So what I have to do? Carbon solid to first carbon gas. So that is delta H sublimation. After that, once I am having that carbon gas plus H2 gas, everything in gas, then I can apply summation of bond energy of the reactant minus bond energy of the product. So basically delta H of this reaction, which is representing the enthalpy of formation of CH4, I'll be writing this as delta H sublimation of the carbon solid plus summation of bond energy of the reactant minus bond energy of the product. So for sublimation it is X1. For the reactant, here once it gets converted into gaseous, there is no bond. H2, for H2 I have given you X2s, but there are 2, so 2X2. Now in the product you are having 4 bonds, so 4X3. That should be your answer, and in fact majority of you have done it. And those of you who have not understood how come directly I have written, for them I am splitting in them up, okay. That is only for making you understand. That's not the entire method, that is the enlarged method, or is bigger method actually. But that will clarify your understanding. So what we are doing, carbon solid to carbon gas, delta H1 which is equal to delta H sublimation, that value is X1. Once it is gaseous form, then 2H2 gas giving you basically CH4 gas, and here it is delta H2 where everything is in gas, so I am able to apply summation of bond energy of the reactant minus summation of bond energy of the product. In the reactant there is here for carbon gas no bond. For 2H2 you are writing this as 2X2, here 4 bond minus 4X3. Then when I am adding it together, what it is becoming, carbon solid plus 2H2 gas giving you CH4 gas. So basically delta H for this reaction is going to be delta H1 plus delta H2, which is X1 plus 2X2 minus 4X3. That is your answer. If somebody is not clear, they can always understand like this. Okay. So we'll wind up here only our session, right? And this question which I have given you, this is normally not asked that much, but rarely it is asked. You should have idea about it. Okay. Otherwise, simply bond energy reactant minus bond energy product, you can easily go for it. Okay. So that's all. We are winding it up here, and I'll share the QR code, right? And you scan it and share it in, like, I'll also share it later on. Okay. Fine. So thank you and have a nice day. Madhurika, yeah. 1 minute, Shrikara. Yes, bye everyone. Yeah. Go and have your lunch. Manumika, I think you were asking whether in which group it is shared, but if at all you are permanent member there, then only I'll share in the group. I'll share it in the group. Okay. If you are permanent member, I think there only, then only I think it is getting added. Achha, any offline student who is there in the online group for some time, is it there? Like I'm asking on behalf of another student, because the thing is, I think some confusion is there. Any offline student permanently shifted, then you do one thing, Madhunika, you contact the Prasad sir. He is the admin there. He'll basically add you in the corresponding groups. Right? And accordingly, achha, those who are like temporarily also there, are you even added up in the groups now? Those who are like temporary online students, that means they're actually offline students, but for some time they are there in that particular group. So are you getting everything there? Where hydration enthalpy will come, beta? And Jonathan? From where things are coming up? Rajni and Snehilata, so it will be shared. You people have to just communicate it. So Madhunivika, please contact Prasad sir. He'll basically add you up and then you'll be getting the QR code there. Fine.